All right, so what we're going to talk about today is the first section in chapter 5, which is about the area between curves. So before we begin on that, just a little review about what the geometric definition of an integral is. So if we have an integral of a function where the function is greater than or equal to 0, the geometric interpretation of that would be the area underneath the curve. Okay, so area is equal to the integral from a to b of f of x dx. If we have two curves, then it's not a stretch of the imagination to think of how we would be able to find this little red area in between there, right? Well, if you have the function f, you have an area for its integral. Okay. If you have the function g, well, it'll have its own area. So the way that you find the area between the curves is you take the area from the f function and subtract the g function. And with the properties of integrals, we can evaluate that all at one time. So the area between two curves is simply the integral from a to b of your upper function minus your lower function dx, where in this case f is greater than g. So our first example today. Find the area of the region bounded above by y equals x squared plus 1, below by y equals x, and on the sides by x equals 0 and x equals 1. So it's always a good idea if we visualize what's going on here. So it tells us that our upper function is x squared plus 1, and our lower function is x. So before we even graph this, x squared plus 1, that's a parabola. X is just a line. So we have a parabola and a line. And it wants us to go from x equals 0 to x equals 1. So there's going to be this little tiny area in between here that we're going to be finding the area of. So what we need to do, set it up, just like using the formula it tells us, the integral of 0 to 1 of our upper function, x squared plus 1, minus our lower function, x dx. Now for us, you could just type that into your calculator, all is one thing, evaluate it from 0 to 1, but it's always a good practice to do this by hand. So again, antiderivative of x squared is going to be 1/3 x to the third, plus the antiderivative of 1 is just x, and then the antiderivative of negative x would be negative 1/2 x squared. And we need to evaluate this from 0 to 1. So upper limit minus lower limit, so you take the function 1/3 times 1 to the third power plus 1 minus 1/2 times 1 squared minus the function evaluated at its lower limit, which is 0, which means this whole thing is going to end up being 0. It's a minus sign. Yep, 0. So basically we just have to evaluate what we have on the upper limit here. So 1/3 times 1 to the third power is just 1/3 plus 1 minus 1/2. Again, you would probably be asked to do this problem without a calculator if it was the AP exam, but that equals 5/6, which is 0.83, repeating, rounding to 3 decimal places. So the area between those two curves is going to be 5/6 or 0.83, or the 3 repeats. And we can even check that. We calculate the integral of, oops, just kidding. Remember, upper function minus lower function. So if we just rewrote this as x squared plus 1 minus x, which is what our integral here was, and we regraph that, then we can evaluate the integral from 0 to 1. And we got it right. Okay, so the next example tells us to find the area of the region enclosed by the parabola is y equals x squared and y equals 2x minus x squared. They tell us it's two parabolas, but they don't tell us which one's the upper one and which one's the lower one. So we need to kind of think on that. This one is going to open up, right, because it's positive, so we know that this one opens up like this. This one, the x squared is negative, so it's going to open down, but it's going to kind of be hard to maybe visualize what exactly is happening unless we graph it. So y equals x squared, y equals 2x minus x squared when we graph that. So it turns out it's kind of hard to see, but our upper function, let's zoom in. Let's set the window from -5 to 5. So we're talking this little area right in here. So it turns out that this is our upper function because it's above the x squared function. So this is our lower function. Now we need to see our upper and lower limit of integration there. It looks like they intersect at 0, and it looks like they intersect at 1. That is indeed the case here, but you can always check to see that by hitting second calc, intersect. Okay, if we know that it looks like we're going to approach at 0, choose a point to the left of 0 on the first curve, and a point to the right of 0 on the second curve, and then guess, and it'll tell you, look, okay, they intersect at 0, 0. So our lower limit is indeed 0, x equals 0. To find our other limit of integration, we find the intersection. So we want it to focus between the left and right here to find this other point. So we'll go to the left of that point, and then go to the right of that point, and then again hit guess, and it turns out that our upper limit is indeed that 1. Okay, so setting up our actual integral then. We have the integral from 0 to 1 of our upper function, 2x minus x squared, minus our lower function, x squared, dx. You could integrate it as is. I would recommend simplifying it first, negative x squared. So you actually have 2x minus 2x squared dx. So now when you take the antiderivative of 2x, well, that's just x squared. Because again, power rule, 2 times x minus 1. Okay, so you'd have 2x there. Here you would have x to the third. So 3 times what number is negative 2? Well, negative 2/3, actually. And we need to evaluate that from 0 to 1. So upper limit, you have 1 squared minus 2/3 times 1 cubed minus your lower limit, 0 squared minus 2/3 of 0 to the third, which again happens to be 0. It's not going to always be that way, but here you have 1 minus 2/3, which is 1/3, minus 0 is just 1/3. So rounding to 3 decimal places, you'd have 0.3 repeating. And again, you can check that. Our upper function was the 2x minus x squared, so I'm just going to minus another x squared here, regraph it from 0 to 1, 0.3 repeating. So on your own, I have a little diagram here for you. Here are the two functions, x squared plus 3 and x from -1 to 1. Find the area between them. Go ahead and pause the video to do that. Set it up. And then hopefully you get that as your answer.